Hi everyone, how's the spring break? I bet it's good. So, we're from group 14, we're gonna do problem 833 about conjugate beam. I hope this video solution gonna help you to understand better about conjugate beam problem. So, let's get started.
So this is the free body diagram. We have to find reactions at A. We have normal vertical force and moment at A. And to find the vertical force AY, we must use summation force in y direction equals to 0. And then we get AY equals to 6 kips pointing upwards. And then to find the moment at A, we must use summation of moment at A equals to 0. And then we get moment at A equals to 70 kip feet anti-clockwise. And from the reaction that we have found, we can produce curvature diagram. This is minus 70 kip feet per EI, and this is the 20 kip feet per EI.
Okay, so the next step, from the curvature diagram we can find the conjugate beam of the problem. We know from the originally the problem at A, at A is the fixed end, and we can transform it from the curvature diagram from the fixed end become the free end. And it's also from direction at C, from the free end become the fixed end. And in the problem we need to find the slope at C and the deflection at C, which is from the conjugate beam. The deflection at C is same as the moment at C, and the slope at C is same as the deflection shear at C. And basically right now we want to solve it as a statistical problem and to the next step.
So after finding the conjugate beam, we can move on to finding the slope at C. So finding the slope at C is equals to finding the shear at point C axis. So the shear at point C axis, we can find it by finding the area of the external reactions on conjugate beam. So this is the area of the rectangle of area 3. This part is the area of the triangle at area 2, the small one, and then this is the area of area 1, the triangle of area 1, and then that came to the conclusions that the shear at C axis is equals to 75 kips feet squares over EI, which equals to 75 times 12 squared kips inch squared over EI. We have to be careful of the dimensions. And then after plugging the E and I, we can find that the theta C is equals to negative 0.46 times 10 to the negative 3 radians. So after finding the slope at point C, we can move on to find the deflection at point C. And to find the deflection, we can just find the moment at the point that we want. So for this case, we have to find the moment at point C, which can be found by just adding the area times the distance of the centroid from point C. So on this is the area of the triangle 2, and then times it by the distance of the centroid from point C, which is 15 plus 1/3 of 3.33, and then add it by the area of rectangle 3, and then times it by the distance of the centroid from point C, which is 1/2 times 15, and then area of the triangle 1 times the distance of the centroid from point C, which is 2/3 of the 11.67 plus 18.33. Then we can find the deflection at point C is equals to minus 7878.166 over EI. But we have to be careful of the units, so we times it by 12 to the power of 3. And then we can find that deflection at point C is equals to negative 0.587 inch. Thank you for your time, and we hope that this video solutions will help you to understand more about conjugate beams problem. Thank you.